Greetings and welcome to today's session of your musculoskeletal system course. We're going to be continuing with the joints of the lower limb. This is going to be the last video in the series and we're going to be covering the ankle joint. Okay, so by now you should be familiar with the objectives or general concepts of joints, and you should also be familiar with terms like capsule, ligament, and articular cartilage. So let's go ahead and get started. The ankle joint is the joint that connects the leg and the foot together. It is a hinge type joint, and the bones that are involved in this formation are the talus, the fibula, and the tibia. Okay, so we're looking at an anterior view of the ankle joint here. Okay, you can see how the lower end of the fibula and the tibia are attached together, and then you've got the talus fitting into the lower end of these two bones to form the ankle joint. So the articulations between these three bones that form the ankle joint occur as follows. The lower ends of the tibia and the fibula are strongly bound together at a joint called the distal tibiofibular joint. They form a bracket-shaped socket, which is called the mortise. And then what happens is that the body of the talus fits into the mortise and then forms the ankle joint. So in an x-ray, okay, this is where the distal tibiofibular joint is. And you can see how the lower end of the fibula along with the lower end of the tibia kind of form a bracket shaped socket. This is the mortise. And then the talus just kind of fits comfortably into that bracket. The capsule of the ankle joint surrounds it completely, and it is attached to the lower ends of the tibia and the fibula, and it's also attached to the neck of the talus. In order to allow free movement, the capsule is thin anteriorly and posteriorly to allow easy movement in that plane. But it is thickened laterally because it fuses with the joint ligaments in order to provide support on the sides of the ankle. In terms of movement, like I said, it moves in two directions because it is a hinge joint. The first type of movement is what we call dorsiflexion. This is also referred to as extension. And basically just think of it as you're bringing your toes upwards. This is where the dorsum of the foot is brought closer to the leg, and this is a function of the anterior leg muscles. The other movement that happens at the ankle joint is plantar flexion, and sometimes this is just simply referred to as flexion. And it's basically movement in the opposite direction. So the dorsum here is moved further away from the leg. The heel is lifted off the ground and the toes are pointed downwards. So think of it kind of like ballerina. Okay, when they point their toes to dance, okay, that is plantar flexion. And this is a function of the posterior leg muscles. So with this picture here, you can see where the ranges of movement are for the ankle joint. Here, with the toes being brought upwards and the dorsum of the foot closer to the leg, this is called dorsiflexion. And then when the dorsum is further away from the leg and the toes are pointed downwards, this is plantar flexion. Okay, so we've seen how the capsule surrounds the entire joint. And we've mentioned that there are ligaments that support the ankle joint. So if we take the ligaments, we've got one on either side. The first one we're going to look at is the medial ligament. And this is also referred to as the deltoid ligament. Okay, so if you read medial ligament, deltoid ligament, it's all the same. The deltoid ligament is attached to the medial malleolus of the tibia. And then what it does is that it splits into four separate ligaments. So it fans out into four parts. And these parts, or these four separate ligaments, attach to the talus, the calcaneus, and the navicular bones, as well as some extra attachments. Okay, the function of the medial ligament is to prevent over-eversion of the foot. So remember, eversion is when you move your foot outwards, okay, to the side. So what the medial ligament does is that it only allows eversion to a certain degree, and then it can't be pulled beyond that level. Okay, so that prevents over eversion of the foot. Okay, so this is a picture of the deltoid ligament. You can see how it has one attachment to the medial malleolus, and then it splits into 4 parts, each one being attached to its own part of the foot. On the other side, you're going to have the lateral ligament, and the lateral ligament originates from the lateral malleolus and then has 3 separate ligaments that are considered as one. So it's not like the medial ligament where we had one origin and then it split into 4 separate parts. These are actually 3 separate ligaments, but they're considered as one ligament, and they all have some attachment to the lateral malleolus and then another attachment somewhere else. So we've got the anterior talofibular ligament that attaches between the lateral malleolus and the lateral aspect of the talus. You have the posterior talofibular, which attaches between the lateral malleolus and the talus, except this one is attached to the posterior aspect. And you have something called the calcaneofibular, which also attaches between the lateral malleolus and the calcaneum. So you can see how each one has an attachment to the lateral malleolus, but then it has a distal attachment on another bone. The function of the lateral ligaments is to prevent over inversion of the foot. Okay, so again, inversion is movement or twisting of the foot towards the inside. And then with attachment of the lateral ligament, it's only going to allow the foot to be pulled inwards to a certain degree, and then it won't stretch beyond that level. And so this prevents over inversion of the foot. Okay, so this is just a picture showing you the lateral ligaments. Okay, so you've got a few, like I said, they all have some attachment to the lateral malleolus, and then they attach somewhere else. So for example, here you've got the talofibular between the lateral malleolus and the talus. Here you've got the calcaneofibular between the calcaneum and the fibula. Okay, so they all have an attachment to the lateral malleolus plus another bone. So let's look at the patterns of injury that happen in the ankle. And in order to understand this, you need to understand something called the ankle ring. Okay? Now, when you're looking at the ankle in a coronal plane, so basically think of it like you're looking at the ankle from the back, the structures that form the ankle actually end up making a ring. Okay? So the upper part of the ring is formed by the lower ends of the tibia and the fibula. The lower part of the ring is formed by the talus and the calcaneum. And then the sides of the ring are formed by the ligaments of the ankle joint, so the medial and lateral ligaments, okay? So this is the coronal plane of the ankle, okay? And you can see how the structures are forming a ring, okay? At the top of the ring, you've got the lower ends of the tibia and the fibula. Here, lower down, you've got the calcaneum and the talus, and then at the sides you have the ligaments. So it ends up forming a complete ring. Okay, so the degree the degree of injury that happens at the ankle depends on how many points the ring has been discontinued. Okay, so if you have a single break in the ring at whatever point, okay, then this usually means that the ankle is stable in the sense that, yes, it does have an injury, but it's very likely to heal by itself. It might just require minimal support, but the ankle is not completely disabled. Okay, and if it has a double break, it's more unstable because now we have 2 points where the ring is broken. Okay, so a double break is usually where the ankle joint is less stable and might require more intervention in order for it to heal. Okay? So, you have the types of ankle injuries. You have something called an ankle sprain, where there is partial or complete tear to one of the stabilizing ligaments. So this is where there would be a single break, assuming of course it is one ligament that's damaged. This usually occurs with excessive inversion and is most likely to damage the lateral ligament because it's weaker. So ankle sprains usually involve the lateral side. Now, you have something called Pott's fracture, and this occurs with forced eversion of the foot and results in fracture of both the medial and lateral malleoli. So again, this would be an unstable fracture because the ring has been damaged at 2 points, with the tibia and the fibula being damaged. Okay, so this is what a Pott's fracture looks like. Okay, you can see how there's damage at the tibia here with the medial malleolus being fractured, and the lateral malleolus here has actually been displaced in this injury. All right, so that wraps up this session. I hope it was useful for you, and that wraps up the whole lecture of the joints of the lower limb. As usual, I will be available for any questions if you have them, and I hope to see you guys in another lecture soon. All right? So remember to work hard, and you don't have to make a big show out of what you're doing, and let your success make the noise for you. So all the best, and I will see you guys soon.